All right, let's pull back the curtain on the real magic behind modern search engines. In this explainer, we are going right to the heart of how information retrieval systems actually understand us. We're drawing directly from Chapter 9 of the phenomenal guide, AI-Powered Search, and we are going to completely decode the mechanics of personalized search. We'll explore exactly how these algorithms learn from our behavior to deliver precisely what we need, sometimes, honestly, before we even know we need it. I mean, how does a search engine know what you want before you even finish typing? It feels like mind reading, doesn't it? Actually, scratch that. It's not magic at all. It is this incredible, massive application of machine learning, behavioral signals, and some deeply fascinating mathematics. Today, we are going to break down exactly how these engines capture your digital footprints to curate your entire online world. Okay, let's dive into this. Here is our roadmap for the explainer. First, we'll map out the search personalization spectrum. Then decode recommendation algorithms, explore the math of matrix factorization in ALS, supercharge things with vector embeddings, and finally, look at setting the necessary guardrails for relevancy. Starting right off with Section 1, the search personalization spectrum. To really get this, we need to completely reframe how we think about search and recommendations. Treating them as two totally separate systems, that's a false dichotomy. They're literally just two sides of the exact same coin. Let's look at the absolute extremes of this spectrum. At one end, you have traditional keyword search. This is completely user-specified. Imagine you're visiting New York, you open a restaurant app, and you type in steamed bagels. The engine ignores everything else about who you are, what you usually eat, and just rigidly looks for the exact words steamed bagels. Now, at the totally opposite extreme, you have traditional recommendations. This is completely driven by a user profile. It takes zero explicit input from you in that moment and just blindly suggests items based on what an algorithm kind of infers you might like. But the real magic, the sweet spot, is right in the middle, personalized search. This is mostly user-specified, but it's partially driven by an implicit understanding of who the user actually is. So imagine our user is a nurse. She types the highly generic word jobs into a search bar. A pure keyword system is going to just throw doctor, engineer, or chef roles at her. But a personalized search engine, it brilliantly combines her explicit input, the word jobs, with an implicit understanding of her professional profile. Boom. It instantly returns nursing roles in her specific area, right at the top of the list. That is the ultimate goal we're after. Moving along the spectrum to Section 2, decoding recommendation algorithms. Now, what's really interesting about this is how we actually build that implicit understanding. It basically comes down to the holy trinity of recommendation algorithms. First up, content-based recommenders. These look purely at the actual attributes of items. If you're looking at a job posting, it matches based on title, industry, or salary range. Straightforward, right? Second, we have behavior-based recommenders, which you'll often hear called collaborative filtering. These completely ignore the item attributes. Instead, they look at overlapping user interactions. It looks at the wisdom of the crowd. Users who clicked on this, well, they also clicked on that. And third, the real powerhouse, multimodal recommenders. This is a hybrid approach that smashes the first two together using both item attributes and user behavior to deliver the absolute best possible matches. Let's look at the math behind this in Section 3, matrix factorization and ALS. Think of this like a massive automated technical assembly line for your clicks. Collaborative filtering is essentially a completely crowdsourced voting process. And because it relies entirely on seeing what groups of real users click on or buy together, it is beautifully immune to document data quality issues. Think about it. If a product is missing its title or someone messed up the category tags, a content-based engine would just totally fail. But collaborative filtering, it doesn't care about the text. It just sees that, hey, people who bought item A also consistently buy item B. Simple as that. But here's where it gets wild. To make these predictions across millions of users and millions of items, the system uses something called matrix factorization to discover latent features. Let's de-jargon this for a second. Latent features are simply hidden dimensions. When an algorithm analyzes a massive matrix of users and their movie ratings, it mathematically crunches that data down into a smaller set of hidden traits. And here is the secret. The algorithm doesn't actually name these traits. It has no idea what words to use. It just knows mathematically that a specific group of movies share a strong commonality, say what you and I would obviously call an action comedy vibe, and it quietly, perfectly maps users to those unnamed tastes. Okay, so how do we actually do that math? Well, one of the most popular ways to factor these gigantic matrices is an algorithm called alternating least squares, or ALS. It works in this incredibly clever, iterative loop. First, it starts by assigning completely random weights to the item features, and then it just freezes them in place. Next, it uses those frozen items to calculate and learn the best user features. Once it gets a solid read on the users, it freezes the user features, unfreezes the item features, and recalculates those. It alternates back and forth, freeze, learn, least squares balancing the scales over and over again. It does this until both the user matrix and the item matrix are perfectly optimized to predict feature recommendations. It's brilliant.
Let's move to section 4 and see how this builds. Personalizing with vector embeddings.
Now, as great as collaborative filtering is, it has one glaring flaw. And this brilliantly illustrates what we call the cold start problem. Imagine an older iPad model that's been in an online store for a year. It has super rich behavioral signals, thousands of clicks, thousands of purchases. Our collaborative filtering model loves it and recommends it constantly. But now, imagine a brand new iPad model that was literally just added to the catalog today. It's identical, maybe even functionally better. But because it has absolutely zero historical clicks, the collaborative filtering algorithm is completely blind to it. It has no user signals, so it never gets recommended, which means it never gets the chance to earn user signals. It's a hugely frustrating catch-22 known as presentation bias. So, to fix this cold start problem, we bring in multimodal embeddings, which are very often powered by large language models, or LLMs. This is where we seamlessly blend that high-quality crowdsource matching with content baseline matching. Instead of relying purely on clicks, we use an LLM to convert the text and attributes of every single item into dense vector representations. Basically, we are plotting them as exact coordinates in a multidimensional space. We then generate a user profile by averaging the vectors of the items that specific user has interacted with. Now, using a math function called cosine similarity, we can pinpoint brand new items that sit near the user's profile in that vector space, even if that new item has zero user clicks yet. We completely bypass the cold start problem and get the absolute best of both worlds.
Finally, let's hit section 5, setting guardrails for relevancy.
But hold on, if we just let these highly personalized systems run completely wild, they can severely derail the experience. Here's the ultimate pitfall. Just imagine you recently spent a whole weekend researching and buying a new white refrigerator. Because of that, your personalization profile heavily associates you with the appliance and refrigerator categories. Makes sense, right? But then on Monday, you go back to the search engine, and this time you just search for white paper for your office printer. If the system blindly applies your personalization profile across different categorical boundaries, it's going to totally skew your results and try to show you white refrigerators. That is a creepy, weird, and completely counterproductive user experience. Nobody wants that. So, the crucial point here, and this is a recurring theme from the source material, is that truly great personalization is completely invisible. It's captured beautifully in this quote. Apply personalization with a light touch. It should really only be applied within related categories, and above all else, it must always respect the user's explicit query first. If a user tells you exactly what they want by typing it in, the search engine shouldn't try to outsmart them. So, we've covered the whole spectrum of personalization today. We looked at the mechanics of collaborative filtering and ALS, the incredible power of LLM embeddings to solve the cold start problem, and the absolute vital importance of setting proper guardrails. So, I want to leave you with this final thought to ponder the next time you're browsing online. As these algorithms become increasingly sophisticated at predicting our latent traits and mapping our digital intent, are you finding what you want, or is a search engine finding it for you? Thank you so much for joining me for this explainer, and keep questioning the algorithms that shape your world.